Evaluate the definite integral. So, okay, so we're going to do this integral by matching it up with one of these integral formulas. See how it matches? It's more similar to the bottom one. We don't have a root. It's not the top one. So it's this one. So whenever you're going to use an integral formula in math or science, you got to do plastic surgery. You got to give it a new look. Remove the wrinkles, give it a new look without changing its value, right? That's why I call plastic surgery. You got to take this, make it look different so that it matches this form without changing the value. Okay, so how do I do that? Then I can use the formula. So how do I make this match the form of that? What's the form? Something squared plus something squared on the bottom. So I think, oh, okay, so that's 1 squared plus what's that? 3x squared. Oh, so that's my u. That's 1 squared plus u squared. My u is 3x, right? I got to make it something squared plus u squared. My u must be 3x. See how I'm making this into the form of something squared plus something squared. It's 1 squared plus 3x squared. That u is the 3x. So that tells me, oh, okay, okay. So now I know u is 3x. So now I can do the derivative du dx. Derivative of that is just 3, right? One power comes down, subtract 1, the x is gone. Multiply both sides by dx. Gonzo. So du is 3 dx. So now let's bring this guy over here and rewrite this integral. It's the integral of, we're going to do a u sub here. So the bottom is going to be 1 squared plus u squared, right? This is u right there. U is 3x. The top, so, and the top is still got a 4. Well, actually, we can move that 4 to the front. Let's put that 4 in the front, right? Grab that 4 in the front, and we got a dx up there. Now, what's dx? Well, come in here and multiply both these by 1/3. Boom. Dx is 1/3 du. So this dx is 1/3 du. So I'm going to move that 1/3 to the front. So this becomes 4/3. The integral of du over 1 squared plus u squared. Okay, we've done it. What have we done? We've made this look like that, haven't we? Right? Because now it's the integral with a du on the top, a u squared on the bottom, and some number squared. Perfect. With a 4/3 in the front. So that means it's going to equal 4/3. That'll sit in the front. But this integral matches this, which equals that. So that's going to become, watch, let's do this. That's going to come on down here and be 1 over a arctan of u over a. You tracking with me? Right? That's what it says. If you once you've got the integral of this form, it's equal to this. So this is equal to that. Where, what specifically, let's get clear what our stuff is. This is kind of scribbly. What is our A? Do you see it right here? Back to here, our A is 1, our A is 1, and our U is 3x. We know that right here, U is 3x. A is 1, U is 3x, so this is 1 over 1, arctan of 3x over 1, right? Our U is 3x, says that right here, and our A is 1, because this is a squared plus u squared, 1 squared plus u squared. So there's our a right there, 1. Okay, so let's that's what it equals. We did the integral. There's no more integral symbol, right? That's what it's saying. If you have the integral of something of that form, it equals that 1 over a arctan u over a. So we got it. So let's clean that up. That is 4/3 times the arctan of 3x. But now we're not done because this was a definite integral. So we're supposed to evaluate this thing from 0 to, what is that there? 1/3, 0 to 1/3. So now leave the 4/3 just sitting in the front. 0 to 1/3, right? Yep, 0 to 1/3. So you know how this works. Plug in the 1/3. So we're going to get 4/3 sitting in the front. Plug in the 1/3. What are you going to get? What are you going to get? Arctan of 3 times 1/3 minus arctan of 0, huh? So we can go to Desmos and we can say, okay, Desmos, help us out here. What is the what is the arctan? This is going to be of 1, right? Let's go to Desmos. Say, hey, Desmos, what is the arctan of 1? So go to functions, inverse tan of 1. And it is, oh, but we got to be, yeah, it's that number. Arctan of 1.78539. 0.78539. 0.78539 minus, and what's the arctan of 0? So we go, okay, inverse tan. Oops, that is not what I meant to do. Inverse tan of 0 is just 0. 0. So now we just need to take 4/3 times that number we had from Desmos. So I'll go 4/3 times, let's type it in again, inverse tan of 1. And it comes out to be 1.047. 1.047. 1.047. Is that what they got? 1.047, blah, 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 blah. That's what they got. All right. So recapping on this thing, we're going to use a formula. When you use a formula, you got to do plastic surgery, give it a new look so that it matches. To do that, I said, oh, it's going to be something squared plus something squared. That's 1 squared plus 3x squared. So that told me my u was 3x, did the derivative, got the dx alone. Dx is 1/3 du. This dx is 1/3 du. Put the 4 in the front. And then at this point, it matched the formula, so I could use the formula. It's going to be 1 over a arctan u over a. 1 over a arctan u over a. Right there. So we've got it right there. And then plug in the a is 1, the u is 3x, arctan 3x, then evaluate from 0 to 1/3. Plug those in, we get our answer. And so there we go.